All right, so welcome back. So now we are going to transition from what we've been talking about with infinite series now into looking at graphs in some alternate scenarios. Specifically, we're going to be looking at two other systems of how we can construct graphs. One called parametric and the other called polar coordinates. Now, you may have seen both of these before in a pre-calculus course. You might have ran into them before, or a trig class towards the end of the semester. Maybe you might have studied these a little bit, or maybe these ideas are both new for you. Okay. So we begin our discussion with what are called parametric equations. In parametric equations, we define a curve, right, the shape in two-dimensional space that later we usually call a graph, by defining both x and y as functions of a third variable, which is called a parameter. A third variable is called a parameter. Okay, so both x and y are functions of a third variable. T is usually the variable we use, and we think of it usually in terms of time. So previously in calculus, you've looked at problems involving related rates. That kind of is a similar idea, where your two functions are time dependent, your two quantities are time dependent, and they're related some way. Right? There was some underlying relationship between the two. Another context where you can think in terms of parametric equations would have been in pre-calculus when you talked about vectors. Specifically two-dimensional, or in physics you might have done this as well. Right? Talk about a vector as being a horizontal displacement and a vertical displacement. Right? In fact, you remember the notation in the ij vector idea. All right, so you can think of that as well. The horizontal and vertical parts as being two different functions, right? So you can think of parametric equations as looking at the equation for the horizontal component and then the vertical component together. So you're talking in for vector motion. And of course, you could go to parametric equations with three variables if you wanted to, if you're doing something in three-dimensional space. So that's kind of the idea of what vectors are, what vectors are, not what vectors are. What we're dealing with when we talk about a parametric equation. Of course, every function that we've talked about previously can be thought of as a parametric equation, as a special case of a parametric equation where we just say x equals t, y equals g of t. X equals t, y equals g of t, which would just be g of x. Right? So every function that we've ever talked about is actually just a parametric equation where the x variable is the same as the t parameter, and it kind of disappears. So what we're now going to be looking at is, well, what if x is something else? What if x is something else? And how is this different than a regular function? And can we talk about doing things like derivatives with these parametric graphs? Because we're still going to have a curve. So can we talk about the rate of change of that curve? Apply that idea to this thing. So those are some of the questions that we're going to start to ask. And these parametric equations, if you've never seen them before, will start to become more clear as we look at some examples. We'll look at an upcoming example in our next video where we will see that there are circumstances where we definitely would prefer this and actually need to break this up into two separate quantities instead of doing just one single function. Okay, but we'll come up with that in the next example.